Hello, my algebra friends. This is today we're going to do this worksheet together, have some fun applications with the quadratic stuff that we've been working on. So it's meant to be not too stressful because we're going to do it together, but intellectually and mathematically enlightening because some of the stuff is things you'll have to learn how to do anyways eventually. So I thought this would be a good time to do it.
You will need a calculator. So if you have one, go get it. If you don't have one, that's okay. Still follow along and watch the video with me because I'll use my calculator on the screen and show you what we're doing. So let's get right into it. A minute into me talking, we're finally going to get into the problems. In Baltimore, Maryland, home of the Major League Baseball team, the Baltimore Orioles, they sometimes use a t-shirt cannon to launch t-shirts into the crowd. The cannon they used on September 29th of last year launched a shirt that followed a path described by the equation h of t equals negative t squared plus 20t, where h of t represents the height of the launched t-shirt and t is the time in seconds that it was in the air. So what I would like you to do is use your calculator and the equation that was given and complete the table that's shown here. And then once your table is completed, plot the dots and make the graph. All right. Now, the equation is given as h of t negative t squared plus 20t. When you type it into your calculator, you have to use x's, okay? So just make sure you use x's in the calculator. Okay, so go ahead and do that. For those of you that do not have a calculator, you can watch me do it. Negative x squared plus 20x. Strange looking graph, but that's okay. I don't care about the graph on the calculator. I want the table on the calculator. So at x or t is time 0, the height is 0. So at time 0, the height is 0. Time 2, it's at 36, and 4 is at 64. So 2 is 36, 4 is 64, and then at 6, 6 is 84, 96, 100, 84, 96, 100. And then they start going back down. Once they start going back down, I know my values will repeat because it's a parabola, because it has an x squared, or technically a t squared. So I know that it's going to be symmetric. All right, so now let's plot the dots. So 0, 0, 236, 3 skipped, 464, 8, I'm sorry, 684, 896, 10 is 100, and then 96, oops, 80, 84, oh yeah, 84 is up here. Durr. That makes more sense. 64, 36, hey, I'm missing something here. Messing myself up. 0, 36, 64, 84, 96, 100, 96, back down to 84. Oops. then 64, then 36. What did I do? Hopefully you guys are not having as hard of a time as I am. Oh my goodness. 16, 14, 12, 10. Oh, that was the one. This one right here. Holy cow. There we go. Whew. Okay, so sorry about that. Even the best mathematicians make errors sometimes. Okay, so there's the path of our t-shirt flying through the air. So this is a t-shirt cannon, and it makes sense that when the cannon fires the t-shirt, it goes up into the crowd, into the air, and then back down, and somebody catches it or picks it up off the ground. So now that we have all that done, remember that our x values along the bottom are numbers that represent the time, how long the t-shirt's in the air, and along the side represents how high the t-shirt is in the air. So how long and how high. So based on this information, what was the maximum height that the t-shirt reached? Well, the maximum height was 100 feet. How long did it take the t-shirt to reach the highest point? So what is the time at the highest point? Well, the highest point was 100 feet, and that took 10 seconds. I wish it only took me 10 seconds to make the graph. Would have made this video a lot shorter. What was the height of the t-shirt when it returns to the ground? Ooh, that's a tricky question. What is the height of something when it's laying on the ground? 0. 0 feet. If it's on the ground, it's 0 feet off the ground. And how long was the t-shirt in the air? Well, what's our total time in seconds? Launched, max point, and then landed 20 seconds. All right, so that was easy. Number one done. Once we got past all my issues graphing, the rest of it was pretty simple. So this is just a nice application question with all the different things we talked about with parabolas. The vertex is a maximum because it's the highest point, and we knew it should be a maximum because of the negative in front of the x squared. We know how to fill in the table of values. Now we can do some real world applications. The vertex has a highest height of 100 feet. It happened at the middle x value of 10 seconds. Okay, so all that kind of wonderful stuff. So let's look at this one. Mr. Stewart is about to jump off of a diving board into a pool. His path through the air can be described by the quadratic graph shown below. The y-axis represents his height above the pool in yards, and the x-axis represents time in seconds. So we have height in yards and time in seconds. So apparently, what I'm doing here is I'm getting ready to jump off the diving board. I'm going to go whee, splash. I guess that should be blue. And then ripples of water. Okay, so how high up is the diving board in feet? Well, the diving board in feet means I have to do a little bit of conversion here, but the diving board is up here and the ground is down here, but I am told that the y-intercept is 0.5. But what I highlighted or circled up here is our measurement on the y-axis is in yards. So that y value of 5 means 5 yards high. So the question is, do you know how many yards in a foot? So if we are 5 yards up and there's 3 feet per yard, that means we are 15 feet. By we, I mean me on the diving board. I am 15 feet above the water. By the way, that's not really me. This is just a picture I took off Google, but it fits and it's funny. Okay, so quick conversion. diving board is 15 feet above the pool. How long will it take Mr. Stewart to reach his maximum height? Well, according to the graph, what we have shown here, the maximum height right here happens after 2 seconds. What is the maximum height that I actually reach? Well, our maximum height is 9 yards. And 9 times 3 would be 27 feet in the air. I am amazing getting 27 feet into the pool, above the pool. When will Mr. Stewart splash into the pool? Well, I kind of covered up the time with my amazing drawing, but underneath all this is a 5 down here. So my point of impact with the water after being 27 feet in the air is 5 seconds. So it only took me 5 seconds to jump and then splash, sploosh. Write the equation of the parabola representing Mr. Stewart's jump in both factored and standard form. Oh, who made up this question? All this work. Well, factored form's easy. Just find the x-intercepts. And I know my x-intercepts are at -1 and +5. So the factored form would be those roots have to get changed in order to create the factors. So the root of -1 turns into factor of +1, and the root of +5 turns into factor of -5. So that is my factored form. In order to get the, sorry guys, I'm going really fast, but this is just fun for me. In order to get to the standard form, we have to use the box method and multiply that out. So I'm going to give you a minute or two. Go ahead and do the box method, multiply that out, and then we will get our standard form for the same equation. All right, so x times x is x squared. X times 1 is a positive 1x. X times -5 is a -5x. And -5 times a positive 1 is -5. So this becomes x squared. And then -5 plus 1, -5 plus 1 is -4x. And then -5. Now, if you remembered how to factor, this is just backwards from factoring. You take these two numbers and multiply them to get the last number, and you take those two numbers and add them to get the middle number, because that's what we would do for factoring. We would figure out what multiplies to be -5 and adds to be -4, and we would come up with -5, +1. So we are going the opposite direction of factoring, which is multiplication. So you multiply the two numbers in the parentheses to get the last value, and you add the two numbers in the parentheses to get the middle value. That's the fast way. Or you just use the box method, and you can do that too. All right, so again, good times. Never knew you're going to be doing questions about Mr. Stewart jumping off a diving board into a pool, did you? Check out this one. A stunt woman is fired out of a cannon and travels through the air along a parabolic path described by the equation f of x equals -31/30 x squared plus 73/6x plus 50, where f of x represents her height in feet and x is the time in seconds. So we have this wonderfully brave stunt woman being shot out of a cannon up into the air and then coming down somewhere on the other side. Parabolic path. There's a parabola described by the equation, which has an x squared in it. All right, what is her height as she exits the cannon? So if we were to put an x and y axis here, what we're trying to find is the y-intercept. Now, let's think about this logically. If x is the time in seconds, x is time, then what we need to find the height when she first starts. So the height when she first starts means find the height when time is 0. And if time is x, what we're going to do is calculate the function when x is 0. So we have negative 31/30 times 0 squared plus 73/6 times 0, and then plus 50. Now, even though those are tricky fractions, you do not need your calculator to get the answer to this because of the wonderful things he does. Anything times 0 turns into a 0. So that means this turns into 0, goes away. This turns into 0, goes away. So her height is 50 feet. That's not so bad. When will she reach her maximum height? So that means we got to figure out whatever that maximum height is, we got to find when it happens. Now that maximum height is the vertex. And we had a magical formula from a couple units ago to help us find our vertex. That magical formula was x equals negative b divided by 2a. That was the formula for how to find the axis of symmetry of, axis of symmetry of an equation, axis of symmetry of the parabola. So when will she reach her maximum height? Her maximum height will be at the axis of symmetry. So let's plug our numbers from our equation into our axis of symmetry formula. So our A value, as ugly as it may seem, is the negative 31/30. And the B value, as ugly as it may seem, is our 73/6. That means 50 is the C. Okay, so let's do some magic here. X equals negative B divided by 2A. Now, we can let the calculator deal with all the messy fractions. We just need to make sure we type it in carefully and correctly. So let me help you with that. The formula is negative b over 2a. So I want the negative 73/6, but I want that in parentheses. So put parentheses around it. Divided by parentheses 2 times negative 31/30. Typing that in, then hit enter. And what your screen should show you on your calculator is we have the numerator of negative 73/6. Oh, I typed in the wrong number. That's okay, I'll show you how to fix it. I go back, highlight, and hit enter. It came out to be 13 here. See that? I need it to be 31. And now look, if you use parentheses versus if you don't use parentheses around the denominator, it's still okay because it's multiplication. So what I mean by that, if I did the numerator, 73 divided by 6, and that's negative, and then divided by parentheses 2 parentheses negative 31 divided by 30, it looks a little bit different. But because you're multiplying times 2, either one is okay, and you can see that because I got the same result both times. Now, if we want to round this to the nearest whatever decimal, we can take our answer too far. Hit enter, and then instead of hitting enter, hit control, then enter. It'll give me the decimal version. Okay, so there's two ways we could write this. We could write this as the fraction, 365/62, which really doesn't help us as far as time goes. So that's why the decimal is a little more realistic. We have a little better feel of about 5.8 seconds versus 365 60-second seconds. So she reached her maximum height at almost 6 seconds. So it took her almost 6 seconds to reach the maximum height. Now, the next thing it says, find her actual maximum height. So to find her maximum height, we are supposed to take the x value and plug it into our equation. So we are going to find the function which represents her height, evaluated at 5.8871 seconds. So negative 31 30ths times 5.8871 squared plus 73 sixths times 5.8871 plus 50. And it says round to the nearest tenth. So when you type this in, because you're using decimals in the calculation, the calculator will automatically give you a decimal answer. And then we'll round it to the nearest tenth, which is one single decimal place. So pause the video, see if you can type that in correctly, and then come back and we'll see if your decimal matches my decimal. So if you typed everything in correctly, you should get the decimal 85.8131720043. And we are supposed to round that to the nearest tenth. That means one decimal place. So 85.8 feet is her highest, her maximum height. And her maximum height happened at 5.8871 seconds. That would be the coordinates of this vertex. Okay, the 5.8871 would be the x value, and then the 85.8 would be the y value. Lastly, it asks, how long until she lands on the ground? Now that means we need to find the solution and figure out the other x-intercept somewhere over here. So to find our other x-intercept, we actually have to solve the equation. Now, completing the square and factoring is not going to work here, so we are going to use the beast. Yes, We are going to use this monster with our A value of negative 31 30ths, our B value of 73 6, and the C value is 50. I told you this was going to be fun, right? It's a good time. So we got to put all these numbers into our quadratic formula. Now remember, when we're doing the quadratic formula, what I need you to do, what you want to do first, what you should do first, is just calculate the discriminant. Now, just so we're clear, the discriminant is the part that's underneath the radical without the square root symbol. Okay, so if I do this correctly, I'm not putting the square root in here. 73 divided by 6 squared minus 4 times the a value of negative 31 divided by 30 times the c value of 50. That is the calculation that is underneath the square root symbol on our paper. And I get that fraction. So that's the part that goes underneath the square root symbol. So I still have the negative 73 6 plus or minus the square root of 1 2 7 6 9 over 36. And then the denominator, 2 times negative 31 30ths would be negative 62 30ths. Okay, so believe it or not, this radical actually turns into a perfect square. So what's going to happen here is I'll get negative 73 over 6 plus or minus, and the square root of this is actually 113 6. And then this negative 62 over 30 does simplify, but does not divide out evenly. So now technically I can do my squiggle McWiggle here with negative 73/6 plus 113/6 divided by negative 31/15. And then negative 73/6 minus 113/6 over negative 31/15. Now this is why we get to use calculators all the time, because this is getting messy. When you try to type this in, you would have to have all of this in parentheses divided by all of that. And believe it or not, what happens here is this one ends up a negative number, but we cannot have negative time. So we reject that because time doesn't go backwards. You cannot have time as a negative number. Now, when I do the other calculation, we end up with 15 seconds. So it takes her 15 seconds to land on the ground. So after all that, the answer is 15. All right, I think I blew your mind enough. So try the last two. They are much easier, much more straightforward. The answer key is in team, so you can check to make sure you did it correctly. And I will see you soon. So be well, stay safe, and good luck.